Hi, greetings of the day. Welcome to my channel cumulanumbers.ai. My name is Vidya. I am a cloud and AI architect. In the previous discussions, we had discussed computation of time complexity or BigO notations for linear equations and quadratic equations. Today, we'll take a look into computation of linear complexity for the algorithm that's of order n. And here will be 3. We'll now begin to make our hands dirty. Start with the package main. And as usual, we import fmt for printing and logging messages, and then declare the function main, which is the entry point for any Go application. For demonstration of cube complexity, I'm just going to walk through loops. So we'll have variables declared, variable I, j, and tree. Consider 3 loops that runs with increments of 1. For I equal to 0, for I less than equal to n, I is equal to I plus 1. So this will be the first loop. We are not declared n. We'll do that shortly. So I'm going to have second loop incrementing with j. Yeah. And then the third loop with k. Okay. We could do anything here. Simply say fmt dot println or printf values of I, j, k, values of I equal to percentage %d, j equal to percentage %d, k, d. We could pull all of this into a function here, func cube demo, and int. We'll pass the integer there and then take all of this from here, put it inside this function, call cube demo here, and pass n. N can be anything, can be 10. These variables need to go inside this function, cube demo. Yeah, fine. We perform some sanity check as we normally do. We don't want to see errors while we are running. This needs to be ijk, and let's dump it line by line. Okay, now we save it and see the results. We are not concerned about the results. Our primary interest is about time complexity. Yeah, we could also modify this and simply say sum of ijk is equal to I plus j plus k at any part of time. Yeah, again, as I said, our goal is to identify the time complexity. So here we have three iterations, one followed by the other, and each loop has an inner loop which iterates about maximum of n times. So the overall time complexity is n into n into n, which is O of n cube in the worst complexity. Meaning every algorithm now has a worst case, an average case, and a best case. If the hit need to actually run through the entire value or entire list or length, it needs to go from 0 to n, and that will be the worst case. On an average, it will traverse at least half the time, and that will be the average. And the best case is when you hit your expected results or your result that is need to be yielded right in the beginning, and that would be the best case. But for time complexity computation, it's always considered the worst case, which is of n cube. So time complexity of this algorithm is of order of n into n into n. Thanks for watching. If you like the kind of videos that I'm making, consider subscribing. Thank you.